Are you ready to live on Mars? It might not happen for a while, but Elon Musk and NASA recently revealed that astronauts on Mars could become a reality by 2029. How NASA and SpaceX plan to colonize Mars? SpaceX and NASA have been collaborating more and more. NASA and Musk's stated goal is to make humanity a multi-planet species. Hey folks, welcome back to the future space. In this video, we are going to find out about the colonization of Mars by NASA and SpaceX. But before we begin, make sure you subscribe to our channel and click the bell icon so you don't miss any of our amazing videos. And let us dive in. Elon Musk has set an ambitious goal of sending a cargo mission to Mars in 2022. Many in the industry believe that a mission will take place later, closer to 2030. But SpaceX continues to move forward, revealing a new vehicle design in 2017 that they claim makes getting to Mars more affordable. Musk is also looking for these initial missions to kickstart a Mars colony. The Falcon Heavy launch in February 2018 was SpaceX's most recent technological accomplishment, launching the most powerful rocket and the return of its 3 boosters since the Saturn V took astronauts to the moon. The space industry establishment, which once feared tech billionaires like Musk and Blue Origin's Jeff Bezos, now admires the vision these entrepreneurs bring to the mission of space exploration. Benefits of Mars colonization. Mars is the solar system's most accessible planet. Mars exploration could answer questions about life's origin and evolution. Mars could one day be a destination for human survival. There is a chance that new life will be discovered that will impact life on Earth. Explorations like this helps to shape our species and propels the development of advanced technological innovations that benefit all of humanity. The exploration and establishment of a Mars colony demonstrate the U.S.'s political and economic leadership while also fostering a peaceful, international collaboration that reduces political tensions. A mission of this size establishes government-sponsored research bases for the long-term specific advancement of deep space exploration. Mars contains all the raw materials needed to sustain life, including carbon, nitrogen, hydrogen, oxygen, water ice, and permafrost. Challenges of Mars colonization. Costs. President Trump signed Space Policy Directive 1 in December 2017 to organize government, commercial, and international partners to return humans to the moon. The directive lays the groundwork for human exploration of Mars, but without committing to funding for exploration and colonization, which NASA estimated at the time to be $50 to $150 billion over 10 years. The cost is now closer to $2 trillion. Furthermore, maintaining that type of budget long-term appears unrealistic in light of William Gerstenmaier, NASA's program director for human space exploration, announcing NASA's desire to remain on a flat budget. Launch of SpaceX. While scientists simulate Mars missions in the dusty desert of Saudi Arabia, plan to build a large Mars test settlement in Dubai, and companies build rockets in the hopes that they will eventually be the vehicles to take man to Mars, others, such as the University of, believe that the interest in a Mars colony is driven by a desire to explore the universe rather than a desire to save the Earth. Whatever the reason, entrepreneurs like SpaceX's Elon Musk are demonstrating the viability of expanding beyond low Earth orbit with new technologies that enable reusability, ultimately lowering production and launch costs. SpaceX spent less than $2 billion to design, launch, and recover the Falcon Heavy's inaugural launch earlier this year. In terms of space dollars, this is a steal, given that the Augustine Commission estimated 7 years ago that building a heavy launch vehicle capable of transporting humans to Mars would cost around $36 billion. With the combined efforts of NASA, SpaceX, Boeing, Blue Origin, and a slew of other space companies focused on overcoming Mars' enormous costs and technological challenges, traveling to the Red Planet and establishing a Mars colony may become a reality. Radiation. The next challenge for astronauts to overcome in order to land and live in a Mars colony is radiation. According to scientists, colonists will be exposed to radiation levels 8 times higher than the current government-specified limits. According to Space.com, the Mars rover Curiosity calculated an average dose of radiation over a 180-day journey to the Red Planet as the equivalent of 24 CAT scans, which is equivalent to exposing an astronaut to 15 times the nuclear power plant workers' radiation limit. While the Earth's magnetic field and atmosphere protect us from radiation, astronauts traveling to Mars would be exposed to 2 types of radiation that are harmful to humans: photons emitted by the sun and cosmic rays, high-energy atomic and subatomic particles emitted by exploding stars, black holes, and other sources in space. Astronauts face more than just cancer. Deep space radiation will most likely cause vision-impairing cataracts, blood circulation issues, and nervous system damage that could impair cognitive ability in a Mars colony. According to research, when a cell is hit by a cosmic ray, the altered cell sends signals to other cells that cause cancer mutations. The radiation assessment detector on Curiosity is assisting us in better understanding what life on Mars will be like, sparking research into protective suits, habitats, and extravehicular activities. According to a report, NASA has agreed to test AstroRad, a new polymer-based radiation-blocking vest for astronauts, on its next mission around the Moon. Former NASA Planetary Science Division head Jim Green has proposed constructing an artificial magnetic shield for Mars to protect a hypothetical nascent atmosphere from the Sun's proton radiation, which would otherwise blow the air into space. There are many theories and a tremendous amount of research aimed at overcoming the challenges that radiation poses for both deep space travel and the establishment of a Mars colony. If this can be accomplished in a lifetime, Mars colonization is not far away. Safety and health. Other health and safety risks for the long journey to Mars must be addressed by NASA and other space agencies. Space sickness. When living in zero gravity, the tiny gyroscopes in our brain that give us spatial awareness are disrupted, causing astronauts to experience severe nausea. Many astronauts suffer from severe space sickness, and an extended mission would almost certainly exacerbate the problem. Maintaining good mental health and emotions in extreme environments is still an unknown due to the inherent dangers of space travel, reliance on life-saving machinery, radiation exposure, space weather, sunbursts and meteorites, living in cramped quarters, and an unchanging habitat of blackness. Researchers are considering using virtual reality, meditation, and images of nature to combat emotional challenges that may arise while living in a Mars colony. Muscular breakdown. Because Mars has only 1/3 the gravity of Earth, maintaining body mass and muscle strength is difficult for astronauts, who must exercise for 2 to 3 hours per day to maintain muscle mass and cardiovascular fitness. Eye issues. Because of gravity and the movement of eye fluid to the back of the eyeball, the shape of the eye lens changes. Most astronauts who spend time on the International Space Station wear glasses in space and have permanent vision changes when they return home. Coughs and colds. In space, the human immune system does not function as it does on Earth, and history has shown that space bacteria are more dangerous. When living in small confined spaces, such as the ISS or a Mars colony, and breathing recirculated air, any sneeze or cough infects everyone. There is also no hospital nearby if anything develops into a more serious illness. Emergencies. A rescue from the ISS could take a day, but people living in a Mars colony will have to travel for 8 months for advanced medical treatment, so they must be prepared to handle emergencies on their own. The conditions on Earth would be simulated, and astronauts could only hope for a 20-minute time delay. Even on-site emergencies, such as surviving Mars' infamous planet-scale dust storms, must be comprehended in order to forecast emergency procedures. Mars discussion. For more than 40 years, robotic explorers have studied Mars, providing scientists and researchers with insights into its habitat and the viability of man landing and living there. NASA's vision for reaching Mars begins in low Earth orbit aboard the International Space Station, where astronauts are constantly determining the technologies and communication systems required for deep space exploration. There's also a group of scientists and space experts who believe we should not embark on this mission to build a Mars colony, citing the enormous cost, high-risk travel, health concerns, and the unwelcome and dangerous habitat to overcome once there, not to mention long-term maintenance and emergency challenges. Right now, the engineering, analysis, and unanswered questions seem interminable for such a journey. However, the numerous research programs and exploratory initiatives currently underway seek to provide answers and identify how humanity can successfully embark on this endeavor. And that brings us to the end of the video. Feel free to let us know what you think about this video. And if you like this video, then please leave a like and subscribe to our channel for all things. Thanks for watching, and we'll see you in the next one.